Hey guys, welcome. This is our study guide video, so let's jump to it. Number one, AC. AC is a chord, but it goes through the center, so we're going to call it the diameter. AE is going from the center to the outside of the circle, so we'll call that the radius. HD is right here, and this is also a radius just of circle H versus circle E. So another radius. GD is right here. Now GD is actually hitting this circle and this circle at one point, so we would call it, the best name would be a tangent line. FM is hitting my circle at 2 points, so we'll call that a chord, not going through the center, so it's not the diameter. Point F is the point where the tangent line meets, so that's called the point of tangency. H is the center of this circle. AMC, so we're looking at major, minor, or semicircle. If it has 3 letters, I'm guessing it's probably going to be a major or semicircle. I see AMC. Since the endpoints are at AC, which is a diameter, we know that this is a semicircle. And FCM appears to be over 180. So that's going to be a major arc. And DHK is a central angle there. A couple things we didn't see was an inscribed angle, which would be, we don't have a very clear, perfect version of one, but if we went F, M, and then it went all the way up to here, that'd be an inscribed angle. But let's continue on. All right, find the area and circumference of the circle. It gives me the diameter, so circumference is just for this formula is 2 pi r, or we could use pi d since we already have that. It's 16 pi. Area is pi r squared, so we're going to find the radius, which is 8. Pi 8 squared. 8 squared is 64 pi. A bicycle that has wheels with a 28 centimeter diameter. Find the approximate distance a bicycle moves forward during 20 revolutions. Okay, so basically it's asking you what's the distance around the circle, because if it makes 1 revolution, it's going to make that much difference. So I'm looking for circumference, so I'm looking for 2 pi r. Diameter is 28, so we know the circumference is actually going to be just 28 pi. And then we want to do 20 revolutions, so we're going to do 28 pi times 20. So it's rounding us to the nearest 100. So if this was in pi form, we just do 560 pi, but it wants us to multiply it by pi and get a decimal, so we get 1759 point hundredth, so that's 2 decimal places, 29, and that's going to be in centimeters. Find the area of a circle with a circumference of 36 pi, so if I know the circumference, I can set it to this equation here, so we're going to do 36 pi equals 2 pi r. I see the pi's will cancel from both sides, so I just have to divide 36 by 2, which is going to give me 18 for my radius, and then I plug that into the area formula, which is 18 squared, which is going to be pretty large. Number 324 pi square centimeters. All right, page 1 out of 4. All right, the circumference is a circle with an area of this. So now we do it backwards. This time we're going to set this equal to the area formula. So we get pi r squared equals 706.86. So first we're going to do divide by pi. In our calculator, 7.6.86 divided by pi. And it's really close. Really close to 225, so I'm just going to call that 225. R squared equals 225, and the convenient part is when you square root 225, you're going to get 15. So radius equals 15. That means the circumference, which is 2 pi r, is just going to be 2 times 15, which is 30 pi, and that's in inches. All right, so for this next one, we're applying some rules where the arc central angle and its the arc and the central angle are congruent, versus inscribed angle, which is half. So we got to be careful. So CB right here, CB is actually, if we trace it back to FBD, this is, the whole thing is 90 right here. So if I take 53 and I subtract 90, I can actually get CB. So if I do 90 minus 53, I'll get 37 for CB right there. Now AB, I can see that I have, if I cover up right here, I have 180 degrees. So if I take 180 and I subtract the 79 and the 37, I should get the value for that. So a lot of it's finding, diameters help us a lot in these little puzzles to find our answers. So we get 64 for this guy. ED, now we have everything but ED, so we could add all these up and subtract from 360. So 79, 64, 37, and 53. But we know this is kind of like already 180, so I'm going to just subtract it by 180 and 53. I got 127. Now the measure of EBD, E to B to D, so that's everything but 127, so we could just do 360 minus 127, which is 233. All right, so we're doing the same thing, just now we're applying some algebra. So solve for x. Right here again, I look for a diameter. I see this is 180. So I know this is going to be equal to 180 minus 45. So if I do 180 minus 45, I'm going to get that arc measure, which is 135. So I just have to set those equal to each other to solve for the value of x. So subtract 33, we get 102 equals 6x. 102 divided by 6 is going to be 17 equals x. And then FBD is kind of a trick one because I believe that's just 180. Or no, I read it wrong. FDB. So that's 180 plus 28, which should be 208. Not 108, 208. So arc length is when we're going to do the measure of the arc. So here, this is unfortunate, I don't think the letters came through, but we'll just call it AB. So it's the measure of arc AB over 360 times 2 pi r. So length has to do with circumference, area of the sector has to do with area. So we're going to use this formula. 110 is the measure of the arc, and then 18 is the radius. We just kind of plug that in. Just to show it on my calculator, 310 divided by 360. I just do that first, times 2 times pi times 18, and I get 11 pi, which is very convenient. Centimeters. If not, I would round to the nearest tenth or hundredth. If the circle has a radius of 15, solve the length of UXW. So UXW is basically 180 from U to X. From U to X is 180. And then we have to go an additional 90, so that's 270. So we should get 270 over 360 times 2 pi 15. And again, I'll just do that in my calculator. 270 divided by 360, which we know is going to be 3 over 4. Then times 2 times pi times 15. And I get 45 divided by 2 pi. That one I'm going to round to the nearest 10. So 70.7 centimeters. And they're not square because they're not area, it's length. All right, halfway done. Solve for solve for AT. So AT is this arc here. So we have congruent chords. If our chords are congruent, then we know their arcs are congruent. So we know that's 130. So essentially, I just take 260, which is all that, and divide it or subtract it by 360, which should give us 100 degrees. Number 20, we saw a lot of this last week in our review. But this is a radius, so we can draw radiuses wherever we want. That's x. This is going to cut that in half to be 9. So essentially I'm looking at a right triangle that looks like this. And the best way to solve that, Pythagorean theorem. So 10 squared plus 9 squared equals x squared, since x is the hypotenuse. 10 squared plus 9 squared, 181 equals x squared, so square root it. And we get x equals about 13.5. Okay, next. Here we have MHT. So MHT is this arc right here, our angle here, and it opens up to this arc. And then we have MAT, which is this inscribed angle here, and it opens up to this arc. Since they open up to the same arc, those two angles are going to be congruent, so we set them equal to each other. 4x minus 10 equals, that's x plus 20. Subtract the x, we get 3x. Add the 10, we get 30. X is equal to 10. Now it wants me to find this piece, so what I'm going to do is I'm just going to plug it back in here. So MAT is x plus 20, so this should be 30 degrees. Remember, it's a 2-to-1 relationship, so if this is 30, this up here is twice that, 60. And again, remember, it's a 2-to-1 relationship. The arc looks bigger than the angle. Also, watch my fingers. They're really close to each other. By the time they're up there, they're further apart. That's bigger, so that one's the one you're going to want to double, the arc. Use the circle below to solve for each measure. ML is this piece right here. Well, I can see right away that ML is opened up by that inscribed angle. So if I just take 59 and double it, I should get my arc measure. If I can use my calculator appropriately, 118. So that's 118. MJ is what's left over of the 180. So if I do 180 minus 118, I should be good to go with 62. Notice I always draw it into my picture once I'm done. JLK, now JLK is an inscribed angle, and conveniently enough for us, it's opening up to JK, which we know is 134. So we just take 134, and since that's already bigger, we're going to divide it by 2 and get 67. And then JLM is this angle here, which we need another color, which is this guy in here, and it opens up to 62, that MJ, so we just have to take 62 and divide it by 2. That's 31. Those are all in degrees, because their M means measure. So degree, 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 no length. All right, so inscribed angle, again, we start out by just kind of writing like this, and then which one's bigger? 94 should be bigger, so this should be half of that, so I'm going to divide that by 2. So 94 divided by 2 is 47. I'm going to add the 25 over. 72 equals 9x. I believe if I divide that by 9, I should get x equals 8. Just typed in the calculator to be sure. All right, final page. It's the final countdown. Okay. RAI is right there. And IN is 58. And RN is 44. So the convenient thing is this angle here opens up to that arc. And so if I add those two together, 44 plus 58, and I divide it by 2, that should give me this value right here, the 2x minus 9, because it's this whole arc, but remember, arcs are twice as big as their inscribed angles, that's why I have to divide it by 2. So 44 plus 58 divided by 2, so we should have 51 equals 2x minus 9. Add the 9 over, we get 60 equals 2x. X equals 30, and the lights went down in the city. Sorry, my lights went off because I didn't move enough because I have no friends. Just kidding. No, seriously, I don't. All right, 12 is a radius. This is also a radius, so I can make that 12. It's a tangent, so it's going to make it 90. Pythagorean theorem, yes, we are doing that. 12 squared plus 16 squared equals, and this is going to be x plus 12 squared. Now we have to FOIL or box method this. Depends how you learned it. I'm going to show box method for this. So x and 12, x and 12. So x times x is x squared. x times 12 is 12x, x times 12 is 12x, and 12 times 12 is 144. These two values down the diagonal are the same. My computer. Okay.
It's 12x and 12x. Everything's shutting down. So we get x squared plus, that's 24x, plus 144. This is going to be 144, or let's just plug in my calculator. 12 squared plus 16 squared is 400. And so equals that. Now, this one's a little bit trickier than the other ones we've done because the x squared is not going to cancel, so I'm going to have to factor. So I'm going to subtract the 400 out. And so that's going to give me a negative 256. So I get x squared plus 24x minus 256 equal to 0. So I have to factor this. So to x factor, we're going to get negative 256, 24. I'm going to figure out which numbers multiply to that. So I know it's going to be a negative and a positive. And so really we just have to try like different numbers that might go into it. I know 256 is divisible by 16, but that's not going to work. 8 and 32, I think, will be my answer, which sounds good. So 8 and 32, 32 is going to be the positive, 8 is going to be the negative, and so we get negative 8 and 32, so this breaks down to x minus 8 and x plus 32 equals 0, but when I solve for this, I get x equals 8 and negative 32. Can negative 32 be a length, though? And the answer is no, so we just cross that one out, and the only answer is x equals 8. All right, let's get these last three done. Simple rule, these have to be equal to each other. They're tangent to the same circle, so we just set them equal to each other. I love it when you know the rule and the math is easy. Subtract 4x, we get 6x. Add the 19 to 23. 42. Divide by 6. X equals 7. I'll do that all day. Double check we're only solving for x. We are. So we're done. Find the perimeter. Now, this is really cool. Because of what we learned here, we apply this. So this is 28. So that must be 28. If that's 6, that's 6. Now this bottom piece, we know the whole thing's 27, so if I take 6 away from 27, this should be 21. That makes this 21. So what I like to do is I like to find the whole segment. So this is 6 plus 28. So 6 plus 28 is going to give me 34. And this is 21 plus 28, which is going to give me 49. And then I just add the main sides together, not the little ones. That way I don't accidentally double count something. So I get 27 plus 34 plus 49. And plug that in to make sure I don't make a mistake. And I got 110. As my perimeter, no units on that. So we could put a U on it or just leave it. And then area of a sector. So this is going to be 120 is the sector over 360 times, this is going to be pi r squared. So pi 21 squared. And in our calculator, we just do 120 divided by 360 times pi times 21 squared. And we get 147 pi, which is really convenient. And if not, we could put that in decimal form, which is about 461.8. All right, whew, that is done. Hopefully it recorded all of that. All right, we'll see ya.